Oh, not necessarily from all over, which is also nice. All right, so welcome everyone to this session, which continues our introduction to meta science. Today, I'm very happy to introduce to you Professor Alex Holcombe, who's at Sydney University. He'll talk to us about pre-registration. Now, Alex and I have gone back and forth a little bit on this and on these topics before. The one thing I was very impressed with is, now that I'm an associate editor for PLOS ONE, is that, Alex, you were one of the founders of PLOS ONE. Is that correct?
On the foundry advisory board, yes.
Yeah, very cool. So, I mean, Alex has a wealth of knowledge on this topic, and I definitely won't do that justice by introducing him. But to all of you, we'll start the session now. As always, if you have questions, raise your hand. I'll pick you out. If there is something, you can ask questions through the chat, which I can manage as well. I told Alex not to focus on that. We also have a Menti code in the chat that Alex will use to prompt some of your responses, which you can use there as well. Just go to the website, enter the code, and you'll automatically join in the right place. All right, over to you, Alex.
Okay, thanks. Well, I just clicked on something and discovered the chat. Okay, good. If I need to go there. Yeah, thanks to everybody for coming. It's exciting to get to speak to such a different audience than I'm used to. Yeah, I come from psychology, in particular experimental psychology. And as Job said, I've been interested in open science for a long time, 22 years, I think. But it didn't really get, I thought it was just the right thing to do all the way back then, but that was before the replication crisis. But what really has gotten some traction going is that it turned out it shouldn't be just something we're doing out of principle, as I discovered when things got going in the replication crisis in 2012, 2013, because it's sort of the lack of openness and lack of transparency and lack of people trying to do replications and people fooling themselves in their own data analyses, which contributed to a lot of studies not replicating. So today, I want to tell you about one tool we have that can both improve the quality of research, and more specifically, one effect of that is to make research more trustworthy, including increasing the expectation that it might replicate. And I hope all of us want that for our research, or even if we're not doing research, when consuming research. I hope after this, you'll have a better appreciation of how much you should value whether a study is actually replicated, or sorry, whether it's been pre-registered. Yeah, replicated would be even better. But before it's replicated, it helps if it's pre-registered, as I'll explain why. And I hope you'll go to that link there that's in the chat, and it's on my screen, menti.com. So if you go to menti.com, you have to enter a code, which will get you into my little survey. But I'll kick things off, and then we'll try to get some sense of where you're at by going with that survey. So I call it pre-registration. That's what we tend to call it in psychology. But where it has a longer history and has gotten more uptake is in medicine, where it's often called registration. In other words, we write some things down about our study in advance of doing it in a publicly available place. So I want to first explain how bias contaminates results generally, and then we'll get to how pre-registration can reduce such bias. There's some related things that could help as an alternative to pre-registration that have similar effects, which we might not have time for, but if people have questions about any topics, just at any time, please put it in the chat, and I hope we can get to them. And then there's specific websites that help you do pre-registration that we could talk about. But yeah, about the bias, it's not just not very hard science fields such as myself, such as my own psychology, that runs into bias. It even happens in textbook cases that we think of as the most rigorous science, such as physics. So Even in high school, if you took physics, you might have learned about this Millikan's oil drop experiment, this ingenious experiment where you can measure the charge of the electron. And what did Millikan do? He had to mess around with his oil drops and try to get the dry oils to drop just right, and then do this measurement over and over again, and then get the experiment working. So he had this whole lab notebook in which he wrote down lots of observations and how he would tweak things to get the study to work. Okay, so what we can do is, that was around 1910. If we look at the paper he published, we can look at all the measurements that he published, and here's the mean of them, this point, and then we can calculate a confidence interval that we're sure that if the study was redone, it would fall within that range pretty much. And they can see that confidence interval is pretty narrow, the vertical axis being the charge of the electron. But that reflected some kind of bias because he had done a lot more observations than just what he published. He had his whole lab notebook, or if we're doing a behavioral experiment, we might have a lot of participants in a pilot study or some participants we throw out. If we include all of those, or the physics equivalent, the confidence interval gets much, much wider. But these are the observations for this narrower confidence interval that he was, confident in. So that's what he published. So then we can look in history, as of course people physicists wanted to confirm this is the charge of the electron. And then as you go along the decades here, you can see the measurements that were made. And what you'll notice is that the first people after him recorded or published measurements that were quite close to what he measured. And then gradually they got further and further away to this other value. And then with improved techniques, we could be 100% sure that that is the charge of the electron, which is quite different from what he published. Now, what's going on here? Yeah, some kind of bias. And Richard Feynman, the Nobel Prize-winning physicist, explains here. He said, well, what happened? The measurement was a little bit off because he had the incorrect value for the viscosity of air. It's interesting to look at the history of measurements after Millikan published it. What you find is that first people were around what he said, and then it settled down onto a number which is higher. But why didn't they discover that the new number was higher right away? It's a thing scientists are ashamed of. When they got a number that was too high above Millikan's, they thought something must be wrong. Their oils must not be dropping right. And then they would mess around till they got a value that was closer to Millikan's. And the experiment must be working. Now I'll just make my measurements. But that's not actually what was happening. Instead, that Millikan's with himself was biased. So what we have here is that researchers, even physicists, have this wiggle room to get results to be in a certain range that they want by adjusting the experiment, or worse, excluding observations semi-arbitrarily. They may convince themselves that they convince them for good reason, but actually it's their bias operating on them, giving them an excuse, or saying, hey, yeah, you should throw out that one, that's so off, because it's probably because a truck went by and my oil didn't drop right or something. So we can call that hindsight bias, and that's affects all of sciences, I would say. So we need to be able to protect against it, because we do have this human nature that we are the easiest person to fool when we get results that are not what we want. We reject that with prejudice, as Francis Bacon said in the I think it was the 1500s, when he first laid down a founding treatise on what science should be, the Novum Organum. So this has been recognized for 500 years. So the pre-registration can guard against that bias, because what you're trying to do with the pre-registration is commit to exactly what you're going to do, and which kinds of results you might exclude, which kinds of measurements you're going to take as acceptable. Which conditions lead to those measurements, rather than post hoc, after seeing them, coming up with excuses. You need to come up with all the excuses, there won't be excuses, all the reasons that you will be excluding data before you collect the data and aren't happy with the data. So you end up being sort of tied to the mast here, rather than allowing your biases to exert themselves. And we can see in more recent history than the physics example, how pre-registration has helped reduce that bias. So what I have here is a graph of, on the vertical axis, the relative risk of primary outcomes. So these are medical studies where people give some new medical treatment, and they want people to not have COVID or not die. And then they look at the end of the study for the placebo group versus the group given the treatment, how much more likely was for the person to not get COVID or not die or not have kidney disease. And so values below 1 mean that the treatment was effective because the risk went down below 1 relative to the placebo. And what you can see is for all these medical studies that were published up to 1996, so these are all different individual medical studies, all these treatments showed a benefit except for these 4 dots, and then these other 4 dots are also non-significant, but still below 1. But then the medical journal editors were very concerned that that there might be a lot of bias going on, and that in the case of medicine, the way it typically works is you can record lots of different outcomes, like how many days was the person in the hospital, or what did their kidney dialysis level go by, blah blah blah, and then you can look at all these different numbers and then decide afterward, oh yeah, that's the number that really tells us whether the person still has kidney disease, and then you publish that as your primary outcome. But the reason that people were choosing that particular outcome was because it gave the result that they wanted, as we found out, because when the medical journal editors decided, this International Committee of Medical Journal Editors in 2000, to only publish studies in their journals for which people had written down ahead of time, pre-registered, exactly how they were going to treat the data and what was going to be the primary outcome, this is what happened. So here's the medical clinical trials that were looked at in this study after that date. And what you can see is that instead of like almost all the studies showing a big benefit of the treatment, now only like 2 out of 15 show statistically significant benefit. The rest are null results. So this is actually quite scary if you're, for example, taking a medical intervention or drug that was approved before the year 2000, because regardless of whether it worked or not, it looks like the pharmaceutical companies or the doctors doing the studies found a way to make it look like it worked. And you can see pre-registration is quite effective in reducing at least some of that bias. So we'd like to see that in lots of fields, and in psychology, it's certainly been taken up quite a lot, which has resulted in a lot more null results because people were fooling themselves. So actually, if you go to mentai.com, yeah, most of you already have. Maybe I can just get a sense of where you're at by looking at the results there. Although I didn't anticipate I'd have to. Oh, I think I can show the response. If I click on this, hopefully on your device, is anybody who's on mentai.com, can they write in the chat whether they can see
the
results?
We can see it, Alex.
Oh, thanks. Yeah. So, yeah. The question was that I put in the Mentai was what % of published studies in psychology, if run again, would give a significant result in the same direction? Now, we don't know the answer to this, but when it was the first study attempted to answer this, they looked at, I think it was intended to be 100 studies, ended up being 99 or 98 that they could actually do. Yeah, only about 30-some% when they reran the study to the best that they could, did they get a statistically significant result in the same direction. But that was before a lot of this pre-registration kicked in. More studies were getting pre-registered, and also people have started increasing their sample sizes. So we think the numbers are going to be a lot higher than that. But that figure before this kind of thing sweeps through a field, which I think it hasn't swept through the field of some of you in the audience. For example, we published a paper a few months ago in a particular subfield where we looked at 255 papers, and 0 of them had studies that were pre-registered, and 0 of them did they share their analysis code, and in only 3% did they share their data. So we know there's a lot of subfields where basically no one's doing this. So yeah, in case it wasn't clear yet, pre-registration of an analysis plan is committing to analytic steps without advanced knowledge of the research outcomes. That commitment is usually accomplished by posting the analysis plan to an independent registry. So yeah, we want to write down as much as we can about our study does design it ideally, but perhaps most critically, how we're going to analyze that data, including which observations we're going, what would be the criteria for throwing out data points or throwing out observations. So that's a source of bias. Another source of bias is what we call p-hacking, which I'm going to get to. Yeah, so here's some unfortunate practices that in a few surveys, at least 5 or 10 years ago, a lot of psychologists would report. So this first one is what we think was doing quite a bit of the gaming in the medical studies, that failure to report all dependent measures. So you can measure a lot of different things about people. You might have a lot of different questionnaires with different facets or groups of questions, and then afterwards you could decide which ones was the best based on which one gave you the result you wanted, even if you're not thinking you're trying to do that. You can't help yourself but immediately come up with excuses for why the ones that didn't work in the sense of didn't give the result you wanted. There can be other reasons for that you make up. And 67% of psychologists reported doing that in their publications, and about half would say, well, I only publish studies that work, where unfortunately work often means supports their pre-existing hypothesis. And, that's a really hard one because, who has time to write up studies that they don't think actually worked? But pre-registration can actually help with that too, because this might be a result that other people in the field also don't welcome. So you might think you might have trouble publishing it. But if you pre-register the study, then people have more confidence in an unexpected result. The journal editors and the reviewers will have more confidence. And 42% of psychologists reported excluding data after looking at the impact of doing so. So that's where people are doing things like maybe it's a response time experiment, and they're adjusting which criterion they use to throw out outliers, like greater than 3 standard deviations from the mean. If it was more than that many standard deviations from the mean, surely the person wasn't paying attention or didn't understand the task or something. But of course, you could use 3 standard deviations from the mean, you could use 2 standard deviations from the mean, you could do log transform, and then do that exclusion or something because the data's not normal. Like if you've ever had rich data, there's a lot of different things you think about potentially you should be doing. And if you only do those after you look at the impact on the result you want, that's bad. But a lot of psychologists do that. And then there's this is like more about the write-up, where traditionally we're even explicitly told by leading people in our field who wrote books like wrote chapters about how to write a paper in American Psychological Association books, that this is how you should write a paper, that you should get the results and then write in your intro like the theory that would have predicted that, without explicitly saying that you didn't predict in advance. So obviously predictions are difficult, but only about the future. Yogi Berra could have said, not just especially about the future. So predictions after you've seen the results are not impressive, but we can only understand whether a theory is good, or it helps if we know the theory is making predictions in advance that are correct. And this last one's similar. So pre-registration protects even against this one too, because in a lot of pre-registrations you would explain what your theory is and what your hypothesis is. So researchers won't be able to say that they predicted it if that we have this public pre-registration that they predicted something else. Does that make sense? I'd love to hear a question from the chat if anybody wants to write something in. So, I already mentioned this. It's like reproducibility projects in psychology, and yeah, it extends into this is preclinical drug targets in papers like Nature, Cell. Pharmaceutical companies are unable to replicate studies, so this has very bad effect on our health because a lot of drugs are not coming through because pharmaceutical companies are spending time on wild goose chases. So we call that the replication crisis. But yeah, we're doing things about it. That was what I used to. That's supposed to be what I used to look like. And yeah, as I said, this is quite a sea change because we were. Luckily, I wasn't taught by this guy, but he taught that you should write the article that makes the most sense now that you've seen the results, which could be correct in a sense, except that you need to admit that that wasn't the results you expected. So we have a term for that, hypothesizing after the results are known. And it's good to hypothesize after the results are known, but not to conceal the fact that you only came up with this hypothesis after the results are known rather than predicting it. I'm not from Texas, so I shouldn't be allowed to give this analogy, but there's what some people call it the Texas sharpshooter fallacy, where the idea is that what the Texas sharpshooter does is he shoots at the barn wall, and then after he sees where the bullets landed and draws all the bullseye around where the bullets landed. So that's what a lot of us were doing, and we're even explicitly told to do in science is, just see what happens and then make up a theory. And yeah, you should make up a theory, but don't write the paper as if you made up that theory in advance. So if you go back to menti.com, want to see where we're at with statistics here. So I've got a question up in menti.com. What does statistical power mean? So without looking it up, see if you can, it's okay if it's gobbledygook. Most of us haven't taken a stats class in a while, but just give us a feel for, it's not gonna have your name attached. So if you could just type in the first thing that comes to mind, I'd appreciate that. And thanks for that comment in the chat about a replication effort in sports science. I saw it pop up, but I haven't read the whole chat message. Right now I'm waiting for more people to write into menti.com. Okay, thanks for those of you who've written something in. Now, if you're still on that at menti.com, you will now be able to see what other people wrote in. And the reason I'm asking about this is, power without me, power is the probability, if your hypothesis is true, of you getting a statistically significant result. So I know, especially in sports science, especially as well as certain areas of psychology, it can be hard to get a big sample. Let's say if you're studying elite athletes or just even recreational athletes, they're busy. So getting a large number can be difficult. And so what we end up seeing in a lot of fields is small sample sizes. That is, not a lot of data points in the study. And what that results in is low statistical power, meaning that even if, this new protocol you have for like improving passing by soccer players or something, even if that protocol actually works, if you don't test it in a large number of people, the probability that you will get a big enough difference in the data that you will get a p-value, a statistical of significance, like a p-value of less than 0.05. I know not everybody is familiar with p-values, but that you will get a big enough difference that will be declared statistically significant. If you don't have that many players that you've recruited, the probability that you'll get that correct result is low. That means low, what we call low power. And that has really contributed to the replication crisis, especially because of the second thing, selectively reported studies that worked, because the journals, as you know, they each of them thinks they're the special, cool, fancy journal, and so they just want to publish exciting things. Nobody wants to publish the boring null results. So they just put the screen on some of them of only publishing statistically significant results. But if everybody's doing low power studies, then actually a high proportion of studies that clear that barrier will actually be null results. Why? Because even the results that are even the hypotheses that are true are often not getting statistically significant. And we know that for ones that are not true, at least 5% of them will get statistically significant. So if a lot of the ones that are true are not getting statistically significant, then we end up with a lot of results in the field that are wrong. Sorry, that was a little bit of a complicated chain of probabilistic reasoning, but the takeaway is low statistical power is a risk factor for your literature having a lot of false positives, because they end up making a high proportion of those that clear statistical significance. So I'm just looking at what you guys wrote in. And you all, I think, are at least on the right track, if not exactly correct. Someone wrote down the power to strike down the p-hackers. That was probably meant to be just a humorous thing rather than being a technically meaningful one. But I mean, even if you have high power, that's if assuming your result is true, you will get statistically significant results. But it doesn't necessarily protect against p-hacking, because you might be wrong and maybe your result is not right. So even if you have high statistical power for gaining statistical significance, if your hypothesis is true, nevertheless, if your hypothesis is false, and you can still p-hack your way to statistical significance. So it doesn't necessarily strike down the p-hackers. For that, we need something like pre-registration. But Job helpfully chimed into the chat saying, in our field, researchers have started to equate pre-registration with research quality, which is obviously false. And I think he's saying it's obviously false because, yeah, pre-registration is only one ingredient that suggests research quality or is correlated with it. There's a lot of different things that go into research quality. One is high statistical power, which typically means large sample sizes. That would be another part of research quality, because you're more certain about the results, and it's more likely the study will result if your hypothesis is true. Your study will work. Okay, but then Job goes on to say, yeah, pre-registration is a step to more rigorous research, but many pre-registered studies can still be conducted poorly. What do you think? So yeah, this is only a small part of research quality, and not only can all the other elements of the study go wrong or be done wrongly, but also the pre-registration can be done wrong, which, since my remit here is talking about pre-registration, I should talk about doing pre-registration specifically wrong. So let's try to get to that. And it'll give me some grist for this if you answer the next question on mentai.com. What kind of study do you typically do? Or if you don't do studies, if you could answer, choose what kind of study do you typically read about in whatever capacity you have of consuming research. And I apologize if your category isn't even on here. If so, please write it into the chat. While some of you are still doing that, yeah, I want to finish the point about p-hacking, because I know not everybody's real familiar with it. Unfortunately, this illustrious, some of us no longer consider him illustrious, this I would call disgraced psychologist. This is what he prescribed for analyzing data. He said, examine your data from every angle, analyze the sexes separately, make up new composite indices of your measures, average together, these 3 questions, but not these 2 questions, because you can look at the data and be like, oh, those 2 questions didn't really work. I'll just average these questions together. If a datum suggests a new hypothesis, try to find further evidence for it elsewhere in the data. If you see dim traces of interesting patterns, try to reorganize the data, bring them into bolder relief. In other words, it's talking about remixing your data every way you can to find something interesting. If there are participants you don't like, or trials, observers, or interviewers who gave you anomalous results, drop them temporarily. Go on a fishing expedition for something, anything interesting. And he even adds, no, this is not immoral. And yeah, discovering stuff is not immoral. Discovering stuff is what we're in the business of doing. There may be one of those little things you can find in a corner of your data set is a new, interesting, and true result. The problem is that he didn't say that you should disclose this if you read his whole chapter. He just said, write the paper then based on whatever interesting thing you found. So looking at interviews with him, I think he just, like many researchers of that era, just didn't understand how easy it is to get a result, a statistically significant result, if you collect enough data, regardless of whether anything is, if it's just random numbers. So even if it's just random numbers, if you do everything he said, you're almost guaranteed to get a statistically significant result, even though there's nothing in there. But him not understanding statistics well had no ability to appreciate that. So, but that's what we call p-hacking. And if you've taken a stats class, you might have heard of correction for multiple comparisons, because, and thus you already were introduced to the idea that the more analyses you do, the greater the chance it is that you'll find a statistically significant result, even if there's nothing there. So we have to correct for the number of analyses you do. So that's one way of dealing with it. But you know what? If your theory predicts that you should do a few different analyses, you don't need to do this correction if you just write it down in advance in a pre-registration. If you lay out that your theory says we should do the following analyses, then the way we think about it is, yeah, that's just what the theory says we should do. Those analyses we should do. It's not really a unfair having lots of different chances to get a result and then forgetting the rest kind of thing. So pre-registration kind of relates to that issue in that way. I hope that made sense, but try to ask a question if it doesn't. And so going back to the slide, we can see that in the audience here, most people do experiments and with multiple factors. I should have said one. I don't know why I said one or more here. And then, but a similar number of you do observational studies as opposed to actual experiments. But both of these things apply. These issues, I think, apply to those equally. But if you are unsure, please type in a question. And I'll go ahead and address what Job has, another thing is written in. So Job mentions that Daniel Lawkins has written about deviations from pre-registration. So yeah, we're getting to the advanced point. So let's see if we get a little further to where that might come up. But I just want to show you, here's a quick example of the kind of thing we used to see in one of the flagship psychology journals, which now a lot of us think is probably, or has high risk of being a false result due to p-hacking kind of thing. So we used to, in our flagship journals, see all these kind of counterintuitive, cute results like being overweight buffers Asian Americans from prejudice against foreigners. The idea being, I mean, they did this study, which I suspect wasn't originally specifically to investigate whether Asian Americans specifically, by being overweight, get less prejudice. I suspect they were doing a more general prejudice study, and then analyze the Asians separately, as that guy recommended, and maybe they even analyze the men and females separately and say overweight Asian men were perceived as less likely to be in the United States without documentation than normal weight counterparts. So, you may understand the stereotype going on here that Asian people are stereotyped as not being overweight, but Americans are stereotyped as being rightly as being overweight. And so if you see an overweight Asian man in America, the idea is that people are more likely to consider that person a more true American. This is all in inverted commas. So, but they're looking at something specific to that race category, specific to that gender, is what they're claiming this discovery is about. So this has all the signs of p-hacking, where they did a lot of subgroup analyses. Now, this result may be true. In fact, it's somewhat intuitive, and maybe it's right, but it has a high risk of only having come about because they did lots of different analyses, and so we can't have any confidence in this result. Now, if they had pre-registered that they specifically had this specific hypothesis rather than that they tested 12 other different things, then we could have more confidence in that, and that's what I'm hoping those of you who are researchers will go on to do. Maybe a catchy way to help you remember this or communicate it to others is that, there's exploratory research where we just look at, and that's fine, to look at individual patterns in the data and say, oh yeah, there's something here. But when we're looking at very rich data, where there's always going to be something there, but we can't be sure that it wasn't due to chance until we do what we call confirmatory research, where we make a prediction in advance, as Galileo allegedly predicted when he dropped these two things that were of identical volume from the Tower of Pisa, that they would land at the same time. So he made a very specific prediction. There wasn't a lot of room for different analyses, or it wasn't a rich data set. So that's confirmatory research after he made a very specific theory. But to get there, he had to look at all the planets, or I don't know, the history of astronomical observations and stuff to come up with this idea. And that was exploratory research. But unfortunately, there's a lot of research happening in this gray area that we can express with the phrase, if you torture the data long enough, it'll confess to anything. And so in journals, there's been a lot of different sorts of journal article tracks that have been devised to try to categorize or encourage researchers to have various levels of declaring in advance, in other words, confirmatory as opposed to exploratory, declaring in advance the exact details of their theory and exactly what they're going to do. So you can see the ultimate, to some extent, is called registered reports, where many dozens of journals now, and I think probably potentially in ones that you might publish in, have registered reports where they allow you to submit an article without having collected any data at all yet. You're just basically submitting exactly what you plan to do and your theoretical motivation for that. And that way, even the journal editors are going to make the decision about whether there's a good study without having seen the data, because the data doesn't exist yet. They're going to make their decision based on just how good of a study have you planned, how well motivated is it, and then they say, yeah, we'll accept that. Just collect the data, and it's a guaranteed publication if you write it up the way you said you would, or analyze it the way you said you would. So that's our perhaps one of our most extreme efforts to eliminate bias. So I encourage you to look into that if you're planning to study for the first time, and where you can send a proposal to certain journals. But the reason the title of this talk is something like pre-registration is hard, is it worth it, is because it is hard to write down in advance everything that you're going to do in all of your analyses before you get the data. Especially when it's complicated data, it's very hard to anticipate all the ways that the study can go wrong and your data could not look like you expect it to. And then as soon as you see it, you realize, yeah, I should have thought of that. I should have had an exclusion criterion for whether the participant answered that question wrong, because if they answered that question wrong, they obviously have no idea what's going on. So all their other answers are probably rubbish too. But I didn't think of that ahead of time, so I didn't put it in my pre-registration. So we often find ourselves, those of us who pre-register, in this position, as Job is referring to in this comment, with what we want to deviate from our pre-registration. So Job wrote a principled approach to he's quoting Daniel Lawkins here. Deviations from a pre-registration analysis plan can both reduce and increase the severity of a test. Researchers need to carefully evaluate both the severity and the validity of scientific. Okay, this is quite technical or abstract language, but can you expand on this? What is your perspective on deviations to pre-registration? So we like to call a pre-registration a plan, not a prison, because we know that unless you've done exactly this kind of study before, it's quite likely that you won't anticipate all the contingencies that you ideally would have anticipated. So you make this plan, and the best laid plans of mice and men go wrong. So you realize, oh, I should have also specified that I would log transform such and such data, because clearly the data were not going to be normally distributed, and then we're going to have this other distribution. So then what do? We don't, and a lot of journal editors are on board with this. We don't say, oh, you didn't follow your pre-registration. As long as you disclose, yeah, we did pre-register that we wouldn't log transform. We didn't say we're going to log transform this data, but because of this, we realized we probably should. Now that means there is potential bias in there, because no one can be sure that you only spotted that because it helped get the results you wanted. So it has let more bias creep in, but at the same time, we know there's also legitimate reasons for that. So pre-registration is not a prison. The idea is publish your paper, being honest about what you pre-registered, and obviously you'll link to it. So you have, in theory, you have to be completely honest, because people can read the pre-registration, but we know a lot of people don't. So we've seen lots of papers where people get away with they're probably not lying about the pre-registration, but they conveniently convince themselves that they pre-registered something a little different than what they actually did. But you should strive to be transparent about your departures from your pre-registration. You can have that in a little separate paragraph. Deviations from the pre-registration. So yeah, each time there's a deviation, it allows bias to creep in, but this is going to happen, and I think a lot of journal editors are quite tolerant of that. But if you have if that doesn't answer your question, let me know. So let's go back to the Mentai slide, if you don't mind. I've got another question there for you. Which are reasons to pre-register? So we're at mentai.com. So I'll just do a few more slides and then wrap up, and hopefully I'm hoping that there'll be more questions. We didn't get to the websites that you can use, but okay, thanks for those of you who answered the Mentai question. If you look at your so yeah, actually this is one of those things where I set it up so all the options I consider to be correct. So which are reasons to pre-register? Yeah, it helps force oneself to think through a study. Actually, I hadn't mentioned that yet, but I find that useful with my students. For example, with honor students, but also PhD students. You know, the pre-registration is a time to write down exactly what you're going to do in detail, including your analyses. And it's only when I force a student to do that do I realize there might have been there's often some miscommunication. We were thinking about the study in different ways. And not only that, if I pre-register something myself, even if I'm doing it by myself, I realize as I write the pre-registration down, that there's a lot of things I hadn't thought of yet. And thus, by writing down the pre-registration, I'm actually end up with a better data analysis than I would have otherwise. So yeah, it helps force oneself to think through a study. So that's kind of a useful thing. Which are another reasons pre-registered? Yes, also warding off p-hacking worries. That's what I've been emphasizing. To show the accuracy, inaccuracy of your predictions. Yeah, I like that one because it's amazing how biased confirmation bias humans have, that after we collect data, we convince ourselves that we predicted this all along. That's hindsight bias is a term for that. So we're going to reduce that. And to improve interpretation of p-values. Yeah, the reason that that's also a correct answer, the pre-registration helps improve interpretation of p-values, is that if it's not pre-registered, we just can't know whether the person, when we read a paper, whether they intended to analyze the data that way from the beginning or not. We can't, there's just no way to know whether they p-hacked. Now, of course, we'd like to think that the majority of our colleagues don't p-hack, which might be true, but for any individual paper, we usually don't know that person. You know, some of my best friends p-hack. So even if they're a good person, that doesn't mean they don't p-hack. So we can only really interpret the p-value if it's pre-registered, or else, except in these rare cases where the theory makes a very specific prediction quantitatively that everybody agrees on, like Newton's theory of gravity or something, where everything follows directly from the theory. But that's unbelievably rare in psychology, social sciences, probably sports science. So
Alex, sorry,
yeah.
we just have someone in the chat who's asking if you have any advice for pre-registering very exploratory studies. So she says, I've written up protocols for what I think I'll be doing. Then upon executing it, it ends up being entirely different. I'm concerned about spending too much time writing a pre-registration that ends up being completely different from the actual study, which relates to your pre-registrations hard. Is it worth it? So for reference, I do observational studies on research literature, often using metadata to compare different aspects.
Yeah, so maybe it's not worth it in that case. Yeah, exploratory, thanks for asking that, Annie. Yeah, for exploratory studies, yeah, if you're not sure exactly all the different measures you're going to look at and so on, or you, as you say, when you actually try to do it, you realize you got to do it differently. That's going to tend to happen. That's been my experience. It's the first time I do an experiment on any topic, even if I've done a study on this topic, but but I'm using a different kind of protocol or looking at it. I'm amazed how much I can't think through, or end up not being able to do it the way that I originally planned. And yeah, then it seems like the pre-registration was a waste of time sometimes, and maybe it was in those extreme cases. So it's very hard to make that judgment call, I'd say, because it's hard to know in advance how much foresight, that's what's called, you're going to have. So it's best suited for a study that's a follow-up, or that you've done a pilot study for. You know, if you've done a pilot study, then you typically can anticipate everything. So, or not everything, but well enough to, I'd say, make the pre-registration worthwhile. But there's that brings up, alternatives to pre-registration, which might be useful. I don't know in the kind of cases Annie's talking about, but in some cases. So, there's these cognitive biases in research listed on the top row here, which I think I've gone through all of them probably. But then de-biasing techniques. Pre-registration is what comes under pre-commitment. But there's also a team of rivals, where you have other people on your research team who disagree completely with your prediction. And so you are going to have these different perspectives, and that comes together in the paper. Or you have the people do the data analysis not know the hypothesis, or even better, you unlabel, like let's say it's an intervention test, you delete the labels from the two groups, let's say a placebo group and the treatment group, and you hand it off to a data analyst and say, here's group 1 and group 2. Tell me which one did better. And or you blind yourself. That's what I've done that recently too. And then another one, which is related to pre-commitment, but it's not pre-registration, is is work through your data analysis on fake simulated data, and that's what I've been doing recently. I made simulated data without, even though I have the real data already. I'm running all my statistical comparisons first on fake data that I made up to make sure that it works on the kind of data I think that the real data is going to look like. So I can't make statistical adjustments based on the random way the data came out, which, yeah. So there's that too. Yeah, thanks for the additional. So someone says, just be honest and use open lab book maybe. Yeah, the way I originally got into open science was with before there was even the term open science. Someone invented, a chemist invented this term open notebook science. The idea being, yeah, let's just be, as scientists, be transparent about what we're doing. If someone wants, they can look back through our notebooks and see how our hypotheses evolved. And you should be honest. It helps you be honest with yourself. Richard Feynman said, the easiest person to fool is yourself. But if you have that lab notebook, you can look back earlier in the lab notebook and realize, oh, wait a second, that's not what I was thinking in the beginning. And you can link to that from your paper.
Alex, what do you think of the concept of red teaming, as in working with people who explicitly try to maybe break down or find holes in the things you do? Have you had, good experiences in sports science? There's a few teams like that, but it still doesn't happen often enough. We still are in this kind of protective bubble where we'd rather have people tell us we're doing well than people who are trying to poke holes in the
it's hard
things we
to,
do.
yeah, that's beautiful if you can get a red team, but yeah, it's hard to organize because what's the motivation of the red team to spend all this time on your project, right? Unless they, as you might have been alluding to, already have a strong interest in the opposite side. But it's pretty hard. Maybe your field little area is different, but in most areas, it's very hard to find people who can both clash like that and work together. So, and also the incentives, unfortunately, aren't there. So some colleagues in Europe created something called Red Team Market, where they started a business where they thought that researchers who want to do exactly what you're saying would be willing to hire them to find problems with their analyses and come up with alternatives that might lead to different results. But basically, almost nobody hired them, so that business doesn't exist anymore. So that speaks to the broader thing that we need to change the incentives in academia. Yeah. So yeah, can we maybe formally open it up to?
Yeah. Well, first, let me thank you, Alex, for sharing your wealth of knowledge with us. I realize this is several decades of knowledge in this topic and open science or transparent science. And I'm opening it up to the floor. I know some of you need to go at 4:30. That's perfectly fine. If you want to hang around and you've got a question or two, please do so. I will stop the recording now so you don't feel like your questions are being recorded necessarily, because we only send to whoever's enrolled in this session. We only send the recording there, not actually the questions afterwards. So I'll just stop that now, but please raise your hand if you want to ask a question or type it in the chat for Alex.